on to piecewise functions. I have found these so challenging to graph in XYZ software. But I'll show you what I figured out, and hopefully you can get through this as well. So on our first piecewise function, y is equal to 3 when x is less than or equal to -1, and then y is equal to -x plus 2 when x is greater than -1. So I'm going to go to, I better regenerate. Okay, we're going to ignore that. I just want to use their software to graph the two functions, the function, and not do your problems. Okay, so I need a line that goes at, what was that, x equals 3, a line that goes y equals 3 from here, and you know, I don't, okay, let's try this again. So I double clicked there, I'm going to -1, and I want my line to stop. Okay. The next part of the line I need to graph is y equals -x plus 2. Now that's going to be a line that goes through 2 with a slope of -1. I can draw it really easily with my pen. It's a little bit tougher with the software. So I want to again draw a line, and I want it to start there. I think I have to double click, and then I am just dragging my mouse. I'm not clicking on anything, but I want to make sure it goes the correct direction because it will go anywhere my pencil goes. So I'm being really careful to drag it all the way down here. Now I'm going to double click to make it stop, and I know it stopped because it stopped drawing. Now on the left side of my equation I need a closed dot. On the right side I need an open dot, but that closed dot, it trumps the open dot. So a closed dot on top of an open dot is still a closed dot. So I'm just going to graph the one closed dot. Now, whether or not they make you graph both, I would be kind of surprised. But this is what my graph looks like. So let's go back. I'm going to clear everything. We're going to attempt the other one. So to the left of 0 we have x plus 1, and to the right of x we have -x plus 1. Now notice both of these have the same y-intercept at y equals 0 of plus 1. On the left side we have a positive slope, on the right hand side we have a negative slope. So we're going to go to plus 1. I'm going to grab my line tool and double click. That should pick up my line. Yeah, there we go. And again, I'm just dragging it to make sure it goes the right direction. As soon as I click, it's gonna anchor my line, and I don't want it to happen until I get it all the way across the grid. On the right hand side it's -x plus 1. So again, I'm going to double click there. Click, there we go. Pick up that line, drag it all the way across, double click, and again I have an open dot over a closed dot, so the closed dot trumps. We are definitely defined there at x equals 1. I hope this helps. All right, let's go back and do some different problems. So there's not a whole lot of work to be shown there, just the graphing part is challenging. All right, we're given a graph of this function, the domain of f. They want us to find these values of f at -1, 0, 2, give the domain of f, and also give the x and y intercepts. So let's just start with f of -1. I'm going to go to x equals -1. I'm going to trace it up. It looks like my y value is 3 at -1. At 0, I have both of these lines come in at 0. It's the closed dot that tells me what's happening exactly at 0. So again, f of 0, even though it's a different part of the graph, is also 3. And then f of 2, same idea. We're going to go over to 2. We're going to follow it up, and it looks like we get to 5. All right, the domain of f. The domain of f is all real because these both continue. It is defined all the way up until 0, it's defined at 0, and it's defined all the way to the right of 0, even though there's two separate functions. So in our notation, it's going to be negative infinity to positive infinity. X and Y intercepts. Okay, we have no x-intercepts. It doesn't cross the x-axis. Our y-intercept is going to be at 0, 3. Not at 0, 2 because it's not defined there. All right, that's it for this video. I will see you in class.